To Physics Medzi online tutorial class. All my participants, you are welcome once again. Today we want to study physics again. Now remember, in our previous class we talked about photon as a packet of energy in form of electromagnetic radiation. We equally talked about the particle properties of photon, which we mentioned some of them. They have particle-like collision. They travel with the speed of light, which is 3.0 times 10 raised to power 8 meters per second. We equally say that photon has no or zero mass. We equally say that they can be created or destroyed. Then we talked about the use of photon concepts to explain the particle nature of what? Light, which we say we can explain it using photoelectric effects, or we can use Compton effects. Now today we want to look at the topic fluids at rest and in motion, which we call surface tension. Today we want to look at the topic surface what? Tension. Now we go over to the specific objectives. By the end of the lesson, students will be able to, number one, define surface tension. Secondly, should state the effects of surface tension. Thirdly, perform experiments on surface tension. And fourthly, should state the applications of surface tension. Now, students, I believe you've been observing the surface of water that drips slowly at the mouth of a tap that is not closely tied together. Probably maybe in your school tap or at home. When the taps are not closely tied together, you observe the spherical drop of water at the mouth of that tap. Now, what holds that spherical drop of water together is as a result of the surface tension of the water. As a result of what? The surface tension of the water. Now, the surface of a liquid at rest behaves as if it were a stretched thin piece of membrane under what? Tension. As I've said before, a drop of water formed at the top of a leaf in the early morning or at the end of a dripping tap looks like a spherical water balloon. So you find out that that drop of water at the mouth of the tap is spherical in shape, just like your balloon. Or early in the morning, those of you that have farmland or garden, at the top of the leaf you observe spherical drop of water at the top of that leaf. What holds the water together there to form that spherical shape is as a result of what? The surface tension of the water. It's as a result of the surface tension of the water. Now, this surface tension arises as a result of the intermolecular forces that are holding the liquid molecules together. Now, the surface appears to be under what? Tension, stretched like an elastic skin without what? Breaking. So that surface will not break because of the intermolecular force that are binding that liquid together. So this we call tension. Surface tension arises due to the strong intermolecular forces that hold the liquid molecules at the surface together. It is the tendency of the liquid to reduce their exposed surface to the smallest possible what? Area. Now, if a line is drawn on the surface of a liquid, the force due to the surface tension acts perpendicular to the line and at a tangent to the surface of the liquid. Now let's define surface tension. Let's define surface tension. We have many definitions of surface tension. We are going to see all the definitions. We have about 4 of them. You can choose any one when you are being asked to define surface tension. You can choose any of the words definitions. Now, the surface tension is defined as the force acting along the surface of a liquid, causing the liquid surface to behave like a stretched elastic skin. The force acting along the surface of a liquid, causing the liquid surface to behave like a stretched elastic skin, or to behave like a stretched membrane. So this force that makes the surface of this liquid to come together without breaking, that is the force we call surface tension. That is the force we call surface tension. Now let's see another definition. Another definition of surface tension, or we can define it as force per unit length acting at right angle to one side of a line drawn in a liquid surface. Let's take it again. We say we can define surface tension as force per unit length acting at right angle to one side of a line drawn in a liquid surface. So when you look at it mathematically, we say force per unit length. Force per unit length. So the formula for surface tension is what? Force per unit length. Now from here, we can see the unit of surface tension. Remember, from the formula you get your units. So what is the unit of surface tension? Remember, your force is measured in Newton, while your length is measured in meter. So that means the unit of surface tension is what? Newton per meter. Newton per meter. Another definition, we can equally define it as the work done per unit increase in the surface area of a liquid. The work done per unit increase in the surface area of a liquid. That means mathematically you can equally define surface tension as work done over area. Work done over what? Area. Now from this particular definition, surface tension can be measured in joule per meter square. Joule per meter square. Because your work done is measured in joule, while area is measured in meter square. That means joule per meter square is equivalent to what? Newton per meter. Now let's look at it this way. Remember the formula for work done. Work done is force times what? Distance. So in this case, force F times your distance, which will represent your length. So F times L is for your work done all over area. And remember, area is length times width, or you say length times length. Now, the length up at the numerator, we cancel the length down at the denominator. So here you are equally left with force per length. So you find out that the two definitions are talking about the same thing. Or you can equally define it as, this is the fourth definition, the surface potential energy per unit area of the liquid. Again, we can equally define surface tension as the surface potential energy per unit area of the liquid. Remember, energy is equivalent to work done. Energy is also measured in joules. And now the unit here can equally be joule per meter squared. And remember, potential energy, the formula is what? mgh. mgh, where mg is talking about your force times h. Here the h, which is the height, is talking about the length. Then all over area, which is length times length. So you find out that in this case, surface tension is also Newton per meter, or you use joule per meter square. Now, let's look at the diagram. From this diagram, it will take us to the effects of surface tension. You can see from the diagram a glass full of water. You can see the spherical shape of water droplets. The water droplet from the mouth of your tap. You can see the spherical shape. This spherical shape of this water droplet is as a result of what? The surface tension of this liquid, the water. Then you can see a small insect that is walking on the surface of the water. Look at this insect. What enables this insect to walk at the surface of this water is as a result of the surface tension of the water. That surface tension of the water holds these insects to walk on this water without sinking. You can see a floating needle on water. You can see this needle floating on water without sinking. What is holding it is the surface tension of water. Now, effects of surface tension. Effects of surface tension. So from the diagram we have seen previously, it has equally told us about the effects of surface tension. Now, what are the effects? Number one, insects are able to walk on water. Razor blade or needle or pin, they float on water surface due to what? Surface tension of the water. So they were able to float without sinking because of the surface tension of the water, because of the intermolecular forces that is holding the molecules of the water together without breaking. Secondly, spherical shape of drop of water from water tap. I've talked about that before. The spherical shape of the drop of water from your water tap is as a result of surface tension. We have equally seen it from the diagram. The spherical shape of the drop of water at the mouth of the tap. Another effect, number 3, spherical shape of mercury droplets on a glass surface. When you get a mercury and you drop it in a glass surface, it forms a spherical shape. Remember, mercury is a metal, but it is the only liquid metal. So when you drop it at the surface of a glass, you find out that it forms a spherical shape. Now, number 4, soap bubbles are spherical in shape. When you form bubbles on the soap and blow it, they can form something like what? Balloon. Children used to do that. The soap bubbles, you can use it to form a balloon, spherical shape. What is holding it together is as a result of the surface tension of that liquid. Another effect, bristles of a brush, they stick together when removed from a liquid due to what? Surface tension of the liquid. So the bristles of your brush, when you put it inside a liquid and bring it out, they appear to what? To come together. They stick together. And it is as a result of what? The surface tension of that liquid. Now, let's look at experiments to demonstrate surface tension of water. we have a little experiment that we can use to demonstrate the surface tension of what? Water. Remember, we've said it initially that the SI unit of surface tension is what? Newton per meter or Joule per meter square. And this surface tension is a vector quantity. Is what? A vector quantity. Remember, we've talked about vectors and scalars. Vector quantities, we say they are those quantities that has both what? Magnitude and their direction. But when you talk about scalar quantity, they are those quantities that have only what? Magnitude. They don't have direction. So your surface tension here is a vector quantity. Now we go to the experiment. The experiment to demonstrate surface tension of water. Let's see. What are the things you need for this experiment? You need a small tray, or you can use your petri dish. Then you can use your pure water. Then you use a paper clip, what you use to hold the paper. A paper clip about 3 to 4 cm long. Then you use a filter paper. A filter paper about 5 cm by 3 cm. Now, what are the procedures? Number 1, you fill this tray or the petri dish with pure water, that is 3/4 of its depth, meaning that you will not fill the entire tray, about to full 3/4 or 3/4 of its depth. Then, secondly, you float this piece of paper in the water and place the paper clip on the paper. You float the piece of paper in the water, then you place the paper clip on the paper. Now, what are you going to observe? You observe that as the filter paper gets soaked, it starts to do what? Sink. So that filter paper you put there will start to do what? Sink, leaving the paper clip to float on the water. Remember, the paper clip is more dense, but in this case now, you find out that the paper clip floats on the water surface. The paper clip floats on the surface of the water even though it is denser than water, making a slight depression on the surface. So you find out that this paper clip, despite the fact that is denser, will not do what? Sink. It will just make a slight what? Depression. Now, from the above experiments, it demonstrates the effects of surface tension of water. The water molecules hold the surface together, preventing it from doing what? Breaking. And thus, the paper clip does not penetrate the surface and sink. So as a result of the surface tension of the water, you find out that this paper clip will not do what? Sink. So the surface tension of this water holds this paper clip to stay at the surface of the water without doing what? Sinking. Now let's look at the applications of surface tension. Applications of surface tension. Where do we apply this? Number 1, in the cleansing action of soaps and what? Detergents. Cleansing action of soap and detergents. Now, soaps and detergents, they lower the surface tension of water. Soaps and detergents, they do what? They reduce or lower the surface tension of water. That is why you'll be able to wash your oily material. For you to wash it to be very clean, you can use hot water to be easier for washing. This is desirable for cleaning purposes because the high surface tension of pure water prevents it from easily entering between the fibers of these materials. Now, with a lowered surface tension, the water can wash away the dirty particles. In addition, high temperature decreases the surface tension of water. Thus, it is more effective to use hot water for cleaning purposes. Now, when you use a water with higher temperature, you find out that it will reduce the surface tension of that water, and that is why the dirt will be removed more easier than when the water is not hot. Then another application of surface tension, we apply it in waterproof materials. Now the material that is used to make umbrellas, your raincoats, and other water repellent objects tends to trap a thin film of water between its fibers. You can observe your raincoats, your umbrella, and other materials that are made up of oily repellent materials. You find out that when you are putting on your raincoat, the water cannot penetrate. Rather, they will stay at the surface of that raincoat. So the water will not be able to do what? Penetrate, because of the material is waterproof material. Now, due to surface tension, the trapped water molecules form elastic skin and prevent further seepage. So they can never do penetrate because of the surface tension. Rather, they will form a spherical water droplets at the surface of that raincoat, but they can never do penetrate. So we say that due to surface tension, the trapped water molecules form elastic skin and prevent further seepage of water through the fibers. Often, the material is made more waterproof by coating it with oil-based substances. So these are the applications of surface tension. We apply it in the cleansing action of soaps and other detergents. We apply it in the waterproof material. We apply it in the waterproof material. Now, what are the methods by which the surface tension of a liquid can be reduced? We have two methods of reducing the surface tension of a liquid. Number one, heating of the liquid. So when you heat the liquid, it reduces the surface tension of the liquid. As I've said before, heating the liquid using hot water will reduce the surface tension of the liquid, and that is why you'll be able to wash away your oily plates very easy, because the liquid is being heated, and that heating of the liquid have reduced the surface tension of that liquid. Secondly, addition of impurities such as oil, alcohol, soap, camphor, kerosene, and other impurities. When you add these impurities, it equally do reduces the surface tension of the liquid. Now we go over to our evaluation questions. Now we have said what surface tension is all about. You have equally seen the effects of surface tension. You have equally seen the method of application of surface tension, and we have seen the method by which the surface tension of the liquid can be reduced. We have seen the application of surface tension and the method by which the surface tension of the liquid can be reduced. Now you evaluate yourself using these questions. Number one, define surface tension. Number two, state two effects of surface tension. In fact, this is a question. The way they ask it: define surface tension, state two effects of surface tension, explain one examples of the application of surface tension. Remember the application: we apply it in waterproof material, we apply it in the cleansing action of soaps and detergents. Then number four, explain an experiment on surface tension. And lastly, mention two ways by which the surface tension of a liquid can be reduced. Thank you.